All right, we're going to pick up where we left off in yesterday's lesson, a little abruptly, but we're still working on your skills practice worksheet. We're going to look at two ideas today. One is the idea that we left off with yesterday, and then the other idea is actually with an equation in solving these expressions. So if we recall from our work in lesson 1, we were asked to find the GCF. But if you look here, the only thing that this group of terms has in common is a 1. And so at first glance, it really looks like I can't factor it. But we actually can if we think about it in smaller groups, because the GCF actually is not going to be a monomial, as we will find out shortly. So the hint here is to take and break the expression into two sets of parentheses. So you're going to put parentheses around the first two and parentheses around the second two. Now I want you to, if I could cover this sheet, this slide, I would cover and only look at the first set of parentheses. And I'm looking to see, is there a GCF in the first set of parentheses? And there happens to be a common X between these two terms if I'm only looking at the first set of parentheses. So I can take that common X out, and we can find here that when I do that, I'm left with an X plus 3. So the other piece, then, I'm going to do the same thing and blindly look at only the second set of parentheses, okay? And I would love to be able to cover the first one with my hand or with a piece of paper, but I can't do that through this video. So I'm just looking at this one right here, and I'm looking for the GCF. Now, in this case, the GCF, they're all positive, and there isn't a GCF other than 1, but I can take him out, and I'm going to do that. I'm going to take out a positive 1 from the set of parentheses. Now, taking out the positive 1 isn't going to change what's already in there, okay? So everything here in blue on the right-hand side is related to the second set of parentheses. Everything in red on the left-hand side is related to the first set of parentheses. Okay, and what I'm going to be looking at here is I'm looking to see, is there a common factor between both sides, the red side and the blue side? And I apologize if you're colorblind because of the red and blue. But the idea here is that we have this product right here of this x times x plus 3, and then over here we have this product of 1 times x plus 3. But if you think about what I said it's x times x plus 3, and it's 1 times x plus 3. So interestingly enough, they happen to share this factor here, which is what this is, of x plus 3, okay? And so I can take out that x plus 3, which happens to be in parentheses, and what's left over, okay, when I take that out, if we think about what we've done with our other stuff, I'm taking him out. And because I took him out, the only thing left is the x. When I take this out, because I'm taking out that common factor, the only thing left is the plus 1. He becomes my other term. So if this should look familiar from the end of chapter 7, if I FOIL this, my first two terms, x times x gives me x squared. X times the outer term gives me the 1x. X times 3, the two inner terms, gives me 3x. And the 3 times 1 gives me the 3. Believe it or not, that's the same answer that I had up at the top. Just because the inner and the outer are flipped doesn't matter. okay, because I can move those around. I get that same answer back. So believe it or not, the answer, the factored answer here is that binomial times that binomial that we had in chapter 7. Let's try another one. So we're looking here at first glance. Now this one, there is not a GCF, but what I'm going to do is I'm going to take my pencil, which is what you should be doing, and I'm going to break it up into two groups. So I broke it up into two groups. We're going to look at each set separately from each other, looking for the GCF. So looking at the first group, if you can see that's purple, the only thing they share is a B, so I'm going to take that B out. I'm left with a B minus 2. When I divide that B out, I'm left with B minus 2. My goal is to get a B minus 2 on the other side. So when I'm looking at the right side, which happens to be in red, I'm looking for a GCF. They happen to share a common 3. And I'm going to take out a positive 3 in this case. We'll see that change shortly. But I'm going to take out that positive 3. If I divide out a 3, I'm left with a B. If I divide a 3 out of the negative 6, I'm left with a negative 2. And lo and behold, here they both share that B minus 2. Remember, this is the product of B times B minus 2, the product of 3 times B minus 2. So they share the B minus 2 in common. So I'm going to take out the B minus 2. They both share that B minus 2 in common. Okay. And what is left, that B and that plus 2 becomes my other binomial. Okay, which gives me, if I would refoil this, this would give me B squared plus 3B minus 2B minus 6, which is my goal. This is my factored answer. Try another one. Again, looking at the same idea, I'm going to break this up into two groups, putting parentheses around 2 of the each. Oh, sorry about that one. That got a little out of whack there. Let's see what we have here. Red, I got red. And so in my first group, again, I'm looking for the GCF. The GCF happens to be a 2 and an S. So if I take out the 2 and the S out of both, this is where we got to watch out. Remember, I got to be able to get this back if I redistribute. If I take a 2 out, that leaves me with a 1. Take an S out, that leaves me with a single S. Remember, 2S times S is 2S squared. But 2S times what is going to give me 2S? So I'm dividing these out, but I need that placeholder of a 1 so that I can get that back if I would redistribute. I can't just let it drop out. And that same thing's going to happen on the next one. Is I'm going to take out the positive 3 that they share in common. And when I divide that 3 out, I'm left with an S. But 3 divided by 3, remember, is 1. So you can see here, what do they share in common? But they both share this common S plus 1 as a factor. So we're going to take out that S plus 1 as a factor in parentheses. This helps sets it up for us right away. What is left over? 2S plus 3 is left over, and that becomes my other binomial. Remember, factoring is the idea of taking back what we had distributed earlier. And so to get this 4-term phrase up here, it turns out I multiplied 2 binomials together to get this expression here at the top. So let's try 17 and see what happens. Oh, sorry, I skipped to 16. So with 16 here, I'm going to break it up into two groups. First term has a 2a in common, so I'm going to take out the 2a. That leaves me with an a minus 2. My goal is to get this a minus 2 in the second group. If you notice that in our other examples, okay, we were looking for common binomials in each of these expressions, and that's what I'm looking for here. At best, these guys share a common one, so I'm going to bring that a minus 2 over with the idea that if I redistribute, I should get back the same expression. They both share the a minus 2, so I'm going to take a minus 2 out. That becomes my first factor. And I'm going to take the 2a and the plus 1, which is left over. That becomes my second factor. Pretty neat trick. If I FOIL this out, I'm going to get this guy back up here, and I know I did it correctly. Let's try 17. And the idea, we're going to break it into two groups. This guy is going to be a bit of a mind bender because I'm actually going to take something extra out. So here they share a 2t in common. I'm left with 3t minus 2. Now, interestingly enough, the signs are opposite in this one than they were in our previous examples. And so I need to be able to get a 3t minus 2. Well, this is a minus 3t plus 2. So what we're going to end up having to take out is a negative 1. Because it's the same terms, 3t and 2, but I need to flip the signs. And the way to flip the signs is to take out a negative 1. Because negative 1 times 3t gives me negative 3t. Negative 1 times negative 2 is going to give me that positive 2. Remember, if I redistribute, I'm going to get that back. They share a common 3t minus 2 in common with the leftover 2t minus 1. You refoil all that, you're going to get the same answer back. Let's try number 18. Again, looking for a GCF. This one shares a 3 and an x in common. So if I divide by 3x for both, that leaves me with a 3x minus y. I need a 3x minus y in the other one. They share a 2 in common. That leaves me with a 3x minus y. Take out the 3x minus y, and what is left over? 3x plus, or 3x minus 2, final answer. All right, let's take a look at these last couple, and this is the idea of solving the equation using the idea of factors. We're going to use the idea of the zero product property with the idea that that means that anything times 0 is equal to 0. And so what happens here is we are going to set my equation equal to 0, and I'm going to find out what factors make this a 0. So what we're going to do is we're going to take each of the factors and set it equal to 0 and solve if need be. This one's already solved for itself. I'm going to add 8 over here. X is equal to 8. So the two solutions to this expression are 0 and 8, using the zero product property. Same idea in 20, we're going to let them both equal to 0. This one's already solved for, we'll see shortly where that won't be the case. And then b is equal to negative 12. In a future lesson, I'll share with you what it is we're actually looking for. Again, this one right here, we have two factors. We're solving for which values of m will make this true. I'm going to take each of these and set them equal to 0. Solve for the m. So m is equal to 3. M is equal to negative 5. So the two solutions are negative 5 and 3. Same idea here. A minus 9 is equal to 0. 2a plus 1 is equal to 0. A is equal to 9. Here we have to subtract 1. 2a is equal to negative 1. Dividing by 2 gives me a is equal to negative 1/2. That's a valid solution. Okay, so our two solutions are negative 1/2 and 19. So let's take a look at this guy. This guy is not factored, and that is the first step that we need to accomplish. So we need to take out the GCF. We always are looking for the GCF. And so this guy, I have to factor it first to find out. I have to split apart the x squared to figure out what are the values of that x. X is equal to 0. X is minus 5 is equal to 0, x is equal to both 0 and 5, final solution. Your homework is to work